by creating the digital twin and by being dynamic within the warehouse, we can make storage location recommendations that reduce footsteps, reduce collisions, increase pick velocity. And then when that product is no longer selling or it's no longer seasonal, we'll make another recommendation to move it to the back of the warehouse and move something else to the front. So rather than storing products in fixed bins, fixed areas, just because I store the high intensity bulbs here because that's where I store them, that no longer makes sense.
Growing a business requires a holistic approach that extends beyond sales and marketing. This approach needs alignment among people, processes, and technologies. So if you're a business owner, operations, or finance leader looking to learn growth strategies from your peers and competitors, you're tuned into the right podcast. Welcome to the WBS Podcast, where scalable growth using business systems is our number one priority. Now, here is your host, Sam Gupta.
Hey everyone, welcome back to another episode of the WBS Podcast. I'm Sam Gupta, your host and principal consultant at digital transformation consulting firm Elevate IQ. The legacy warehouse management systems were extremely rigid and imprecise. They had challenges in locating the precise location in the system. They also didn't map humans in the system. These restrictions limit WMS systems to accommodate real-world scenarios such as seasonality and dynamic recommendation of rearrangement of the warehouse based on demand. The modern breed of WMS systems is far more capable with the help of technologies such as machine learning and ultra-wideband. In today's episode, we have our guest, Michael Pytel, who shares how he can create a far more precise digital twin of the warehouse by mapping warehouse workers in the system. He also touches on the deficiencies of legacy WMS systems and their implications on warehouse processes and workers, and how modern systems would make their life easier. Finally, he shares his insights about several technologies, such as how different business systems and warehouse hardware technologies, such as AMR and ASRS, would interplay in his system, and how indoor positioning and 5G would improve the warehouses. Let me introduce Michael to you. Michael is a nationally recognized author and technologist with a focus on digitally connected warehouse management platforms and the broad ecosystem of microservices within the digital supply chain. Experienced in the integration, deployment, and inclusion of machine learning technologies within multiple logistics solutions, Michael enjoys sharing his real-world lessons learned from hands-on delivery of projects. With that, let's get to the conversation. Hey Michael, welcome to the show.
Hey, glad to be here, Sam.
Okay, amazing. And I'm super excited to have you as well, Michael. It's going to be so exciting to dig into all those amazing technologies that you have been working on to automate warehouse. Just to kick things off, do you want to start with your personal story and your current focus, Michael?
Yeah, the story is actually quite funny. You know, I in my late teens, early 20s, worked in a warehouse as a shipping clerk and began to learn IT systems so well. At that time, we were deploying J.D. Edwards. I think a lot of your listeners will know or remember J.D. Edwards.
Yeah.
And the company was rolling out J.D. Edwards, and they said, "Wow, you really learned the system really well. Do you want to join the IT team and be a part of this deployment of J.D. Edwards ERP?"
Yeah.
And so that's how I got my start in IT. I went from the shipping dock to enterprise applications supporting J.D. Edwards, and then through my career supported not only J.D. Edwards and BPIX, but then also SAP over the last decade. But more recently, my focus has been on the digital twin of manufacturing facilities, digital twin of warehouses, digital twin of physical spaces. I even had an opportunity, and this might be another podcast, supported the creation of the digital twin of Levi's Stadium for the San Francisco 49ers. Wonderful project.
Amazing background and story there. And one thing I always appreciate and admire in any IT person is you need to have that ground floor experience in which You have, and that's how you started. But it's quite a journey going from shipping clerk to machine learning. So I am super excited to dig into all of that. Now, we have one of the standard questions before we do that, and that is going to be your perspective on business growth, Michael.
I mean, in terms of my perspective, I mean, every organization, and I'm sure you've talked about this with your guests before, every organization needs to become a data organization. And
Yeah.
we have multiple ways we can use data for analytics, but more importantly, from my perspective, it's data for machine learning, automating decisions and taking people from tactical to strategic. That's my goal in terms of what fuels business growth. It's taking people from the technical day-to-day activities, automating those through machine learning, and
Yeah.
beginning to make your resources or your the people in your organization more strategic.
Okay, amazing perspective there. So let's dig into this whole concept of digital twin. And obviously, when we look at the digital twin, it gets thrown around in a lot of different contexts. And a lot of our listeners are going to be from the manufacturing perspective. So they would have heard digital twin from the shop floor perspective. But now, here we are talking about the digital twin of the warehouse. I have done one episode related to digital twin, and in that, the person commented that, sometimes digital twin could be the marketing hype. At the end of the day, what you are trying to accomplish from the digital twin is you are trying to create the replica of whatever you may have in your physical situation. And rather than going to, let's say, 50,000 square feet warehouse, you have to walk and you have to figure out what is happening in the warehouse. You are really doing that digitally. So before we dig deeper into technology, do you want to walk us through the overall landscape of different warehouse management systems that are out there? What were their challenges and how digital twin is bridging the gap or solving the problem for the warehouses right now?
Yeah, absolutely. So there's lots of players in this space, and
Yeah.
I'm going to list out 10, and there's probably 1,000. So
Yeah.
just want to qualify that with expectations there. In terms of market leaders, you have the SAP of the world, right? SAP makes a product called Extended Warehouse Management. You have Manhattan, which has Manhattan Scale. You have a company called HighJump, purchased by Corver. You have Blue Yonder, which was recently purchased by Panasonic, which is very interesting that a hardware manufacturer is jumping into the software game. Then, of course, we can't mention SAP without mentioning Oracle. You have Oracle Warehouse Cloud, and then you have some other systems. So you have Infor, you have Soft Eon, and Microlistics is a company that's growing very fast right now. We see them as a good competitor. And I should say for your audience, I am a competitor. I am the technology leader of a cloud-based warehouse management platform that creates the digital twin, and that's where we feel warehouse management systems have been lacking. In that, a warehouse management system today, or that I could buy yesterday, it didn't understand the physical space. I could create zones, which might represent aisles or shelves, but it didn't know. It couldn't help you figure out, is bin 1 and bin 10, are they 50 feet apart or 500 feet apart?
Okay.
And so warehouse management systems are also very rigid typically, meaning you have to choose a picking style, whether that's cluster picking, where do I pick in different areas of the warehouse together? Do I do wave-based picking? Do I release a bunch of orders and let people go fill them and then release a second wave? Do I do FIFO, first in, first out, order-based picking? You had to choose a picking strategy and it wasn't dynamic. And what we wanted to do was create a warehouse management platform that is dynamic, that the picking strategy can change day to day based on staff, based on seasonality. The reality of running a warehouse is when you plan on having 10 people at work, not all 10 people show up every day. And you have to adapt and you have to modify. And so what we want to do is create a system that's a little bit more flexible.
Okay, so that's great. And I mean, obviously, we need to dig a little deeper into all of those aspects. And I don't know if my listeners are going to be familiar with the advantages of, for example, you mentioned the zones being 50 feet apart versus 500 feet apart. So why do businesses need to know that in the system? What are the shortcomings? Let's say if I'm using some of the legacy warehouses and maybe I don't know or I don't have this piece of information. So what am I losing by not having this piece of information?
Yeah, great question. So if we think about the digital twin in manufacturing, typically in over the last 5 years, people have been digitizing a machine. an assembly line, a piece of equipment, and you put sensors on that equipment, and you have a digital representation of that machine. Its run rate, its air rate, its measurement of its codes, etc. But what we don't have in that digital representation is the people. The people are not in that picture of that digital twin. And within the warehouse, we create a digital twin of the warehouse that encompasses both human beings and robotics. And so using a fulfilled scanner, we understand a person's location in the warehouse. So they become part of that digital twin map. These are all the shelves. These are all the aisles. This is where the product is. And we understand the XY coordinate of all the product in the warehouse. We have sensors that we put on carts and on forklifts. But in terms of the human being, they're carrying a fulfilled scanner. We know their location as well. And what that enables us to do is much like when you need to take the kids to soccer practice and you got to stop off and pick up some food. You may have to pick up some groceries. You might go to Google Maps and build a route. What's the most efficient way to do these 3 stops? Well, that's what we do in the warehouse. I have a series of orders that I need to get picked. I have a series of items I need to unload a truck and put away. What's the most efficient route for me as a human being to take in picking items or putting away items? How do I reduce my footsteps? So by having the digital twin for the warehouse worker, we can optimize their footsteps, ideally giving that person the ability to do more in a day. Getting rid of the unnecessary footsteps, getting rid of the unnecessary movements, all the travel time delays, reducing collisions and things like that. There's a forklift down an aisle. I can't go down that aisle. I got to go around. All right. Well, what if we had a system that could orchestrate like a delicate ballet of all the people in the warehouse navigating human beings down one aisle, forklifts down another aisle, and organizing everybody's tasks so that the priorities of the organization, right, delivering goods, are being met. That's our vision. Our vision is the digital twin of the warehouse encompasses both human beings and robots and machinery to create that real world picture. And it's real time, right? We're measuring locations 6 times a second. We're creating that real world picture of what's going on in the warehouse right now. What orders are people working on? What putaways are people working on? And what is the general activity in the warehouse? That's my interpretation of the digital twin for a warehouse environment.
Okay, that's very interesting, and I am actually trying to connect the dots. So I can see some benefits based on your explanation so far that you are able to bring that human element along with the machines and the physical structure of the warehouse. But I am still trying to connect the dots overall. Let's say if I look at the day in the life for my warehouse worker, let's say if I had the legacy scenario, and you did mention that, if my picking order is changing every second, every minute, then obviously your system is going to be slightly more dynamic, right? And you can change that based on the way the sequencing of the order is changing probably in the system. So here, let's say if I compare the day in the life for my warehouse worker in the legacy scenario versus the new scenario, can you describe maybe with the example of a story?
Absolutely. So a couple personas we're going to talk about. We're going to talk about one of the warehouse manager or the warehouse lead, and we're going to talk about the warehouse worker. So number one, in the warehouse for the warehouse worker, there is resource turnover. There's a national shortage of warehouse workers. One warehouse is paying $1, $2 more an hour. The warehouse workers leave that one warehouse to go to the next warehouse. Turnover has a high cost because when a brand new warehouse worker starts in that new warehouse, they don't know the storage locations. They don't know the product. Right? They have to do job shadowing for 2 to 3 weeks. And then after a month, they're a fully effective warehouse worker. Well, imagine by understanding location, if that person who's never set foot in the warehouse can find every pick with an accuracy of up to 10 inches, we can navigate them to every one of their activities in the day one. Right? They're using a fulfilled device. We are creating the digital twin. We know where they're standing. We know where the product they need to put away or what they need to pick up is at. So we can navigate those workers. So the real world challenge of onboarding and ramping up new employees is solved by that digital twin. I can just be anybody off the street, come and pick up the device, and I understand where product is. Naturally, if I'm not forklift certified, I can't use the forklift. And that's where some other features come in the app, meaning we hold your certifications and what tools you're authorized to use and things like that. And so we pick tasks for you that you can complete, and then we navigate and show you where to go to get those things done. So that's the one problem we're solving on the warehouse worker side is we're reducing the risk of resource turnover.
Okay.
Now, for a moment, let's move to the warehouse lead or the warehouse manager, right?
Yeah.
The person who's determining what product do I store where. And a very common occurrence or a very common challenge that we have is we will go into a warehouse, we'll look at the structure of the layout of the warehouse, and it typically sometimes it's laid out by product category, product class, meaning for a lighting manufacturer, they put all their high intensity bulbs in this aisle, they put all their LED bulbs in this aisle, and they put all their incandescents in the other aisle. So they've organized their warehouse by product. The downside of this scenario is that product can be seasonal. You can have new product introduction that is moving fast. You can have old products that are moving slow. You can have lots of lights in the springtime being sold because people are out changing their light bulbs, whatever the case may be. There might be seasonality in your business.
Yeah.
And so within our platform, we support what we call dynamic storage locations. Okay. So we look at the history of orders for a 12-month horizon. We look at your upcoming orders, and then we make storage location recommendations. Meaning the warehouse manager today, they don't have the time to sit in front of the ERP system and run a report and look at all the upcoming orders and see, hey, we have a lot of high intensity bulb order coming up. I'm going to go ahead and ask my team to move those bulbs from up high down low to face pick so we can pick them faster, right? The human being just doesn't have enough time in the day to do that. So by using machine learning models, by using our application, by understanding XY coordinates, we're going to make recommendations to the warehouse manager that says, you have a lot of orders coming up for this product. Let's bulk move a bunch of that product from the back of the warehouse to somewhere to the front of the warehouse down low, because we're going to have a lot of orders. We want to increase our pick velocity. So by creating the digital twin and by being dynamic within the warehouse, we can make storage location recommendations that reduce footsteps, reduce collisions, increase pick velocity. And then when that product is no longer selling or it's no longer seasonal, we'll make another recommendation to move it to the back of the warehouse and move something else to the front. So rather than storing products in fixed bins, fixed areas, just because I store the high intensity bulbs here because that's where I store them, that no longer makes sense. Based on order volumes, we can move items and shuffle items within the warehouse to move items that are fast moving to the front and move items that are slow moving to the back, and just create that more dynamic environment to optimize the warehouse flow.
Okay, this is very interesting overall, and I'm still trying to connect all of the dots, to be honest, because obviously it is very new for me in terms of the dynamic plotting that you are doing and the dynamic arrangement of the products that you are doing in the warehouse. So I completely agree with you that, you know what, if everything is going to be dynamic, then you would not require as much training time when you are talking to these warehouse workers. Anybody who is coming on board, then they are going to be familiar because they are probably going to be looking at some sort of screen and they are simply going to follow the lead of the system, and based on that they are probably going to be picking, and this pick location can be changing very rapidly, I guess, in the dynamic manner. But one of the things overall from the warehouse organization perspective, there's always going to be a little bit of mix of the human element as well as your system element, right? So you did mention that you are actually mapping these humans inside your system, so you know the location of the humans, but they are not always going to have a sensor, or they are not always going to have a pick scanner holding. So how do you map the other humans that are there in the warehouse? And since you are changing the layout of the warehouse all the time, so in the traditional sense, I mean, if I go to my warehouse, then typically I have a barcode and I am looking at my organization. Okay, this is my zone, this is my aisle, this is where I store my light bulbs, right? But in the new sense, it's going to be all over the place. So have you found any problems because of this dynamic nature of the system in the warehouse in your experience?
Yes. I mean, well, I would say you bring up great points, right? If I'm not carrying my scanner, my position is not being tracked. And to be clear, that was an honest decision, or it was purposeful, that decision. We did weigh having an employee wear a lanyard, and so they can walk around the warehouse. We track them, but we just felt like warehouse workers or people in general, they don't want to be tracked in the restroom. They don't want to be tracked in the break room.
Yeah.
And so we said, all right, we're going to put and we haven't got into it yet, but we're using a technology called ultra-wideband. We're putting the ultra-wideband chip inside of the scanner and not on a human, because we don't want that person to feel like they're constantly being tracked. But in saying that, the device is providing them their work instructions. And you're absolutely right. If you're carrying the device on your hip, you're going to put it in the holster and you're going to use your hands, or you might set it down on a table, and then you might go do something just because that's real world scenario. Agree 100%. And we don't need physical tracking of everybody all the time.
Yeah.
And we use the data in multiple ways. But to answer your question, we do not track everybody all the time if they're not carrying the device, and that's purposeful. We are playing with technologies around computer vision, so augmenting the data from the scanner with computer vision, so that when someone does leave the device on the table and they walk down and out to get something, we still can maintain visibility into their patterns. Now, why is it so? Now that leads to the next question that a lot of people have is, well, what do you do with the historical information around here? You're capturing everybody's breadcrumb trail through the warehouse. Why is that? And that enables you to do analysis around where is the most picking activity. And if you see, let's say we're looking at a heat map of the warehouse, and at the back of the warehouse it's red because there's lots of activity, then you as a warehouse manager know my people are traveling too far, right? There's too much activity at the back of the warehouse, and we can keep an eye on this, and we can then do some analysis around, well, what product is in those areas, in those storage areas. Why is it in the back? Is it temperature reasons? Is it power reasons? Is it storage reasons? Why? And if it has no good reason for being in the back, you move it to the front. So we collect the breadcrumbs around people's path in the warehouse just to better understand traffic flow. And this can lead to potentially aisle change configuration, storage changing configurations. If you're constantly having collisions between human beings and forklifts, maybe we move to a one-way aisle format to reduce the number of collisions. So we collect location data on device, and that's purposeful. We chose not to track human beings at this stage. And based on customer feedback, that may change, Sam, to be completely honest. They may say, I want everybody tracked all the time. Okay. Obviously, in EU, we have different privacy regulations, but today we do track people with the handheld because that's where they receive their work instructions.
Okay, so any of the technologies that I typically have come across, because obviously I have deep engineering background myself, and any of the technology is going to have a lot of assumptions and a lot of preconditions. Especially when we talk about the machine learning models or AI, they rely on data quality, right? And I don't know whether we are talking about the Fortune 500 companies that might be able to utilize the system, but if you look at the average SMB, their data is really not cleansed. We have hard time, to be honest, implementing a WMS system and the ERP system just because the data is all over the place. And even if I'm doing a plain vanilla demand planning or SNOP planning, it doesn't work just because of the data quality. So in your experience, what are some of the assumptions that your machine learning models have in providing these recommendations, and how off they are going to be, let's say, if the data quality is not accurate as you would expect?
Yeah, no, another great question. And we are a startup in that we are about a year old. We are currently VC funded, and we have our beta customers. And so in that same scenario, it's crawl, walk, run when it comes to machine learning. And so the very first models that we're using in the warehouse are ones that are not heavily dependent upon normalized data from the customer. So as an example, our route, the machine learning model that builds the routes of where to pick product is really based on Google's routing algorithm that they use for Google Maps, right? You have X, Y coordinates of all the product, and we use a machine learning model that generates a suggested path for that human being. So in that scenario, we control the data. So that's the first machine learning algorithm that we deploy at customers. The next ML algorithm that we use, it's a bin packing algorithm. Can this physical object fit in this space? So when we go live at a customer's facility, we have to enroll or essentially do some data entry around the storage locations in the customer's warehouse. So I have this rack and this aisle, and it's 48 inches deep and it's 72 inches high, et cetera, et cetera. We have to record the location, the storage location and the dimensions of the location. And then if we have dimensions of product, we can do a bin packing algorithm, and that goes back to that dynamic storage locations feature function where does this product fit in this shelf, right? That's a question that you can a warehouse worker can physically see if they walked over, but we use a bin packing algorithm, which is another form of machine learning, to say, hey, does this box fit in this shelf? And then there we do have a data quality problem. If a customer doesn't have dimensions of product inside of their material master in their ERP system, then we can't run that algorithm and we can't do that. So it is a challenge. It's something we remind the customer basically through a set of KPIs, their data quality KPIs. Customer logs in, sees a dashboard, and says, hey, we only have dimensions for 10% of your product. And we can't help you be the most efficient warehouse without dimensions for all product because we can't recommend where to store things automatically. And that's what that fuels is system directed put away versus employee directed. The employee directed put away is employee knows best. Employee can see that it's open. Employee is going to put it there. System directed is optimized based on upcoming sales orders and sales order history and seasonality. And where system directed put away is the desired end state. But we do support customers that have a blend, and they do need we do sort of bubble up to the surface the data that they need to improve in order to fully utilize our platform.
Okay, so let's say, and initially you did mention that every single scanner that you have that is actually mapped in your system and that is being tracked as well. So let's say if you are doing this human blending, because you are definitely going to get a lot of exceptions. So let's say if the system is recommending that, hey, human, go there and put the product there. But somehow either the algorithm was off because of data quality. It could be so many different things that could go wrong, right? So that is probably going to be more of the exception scenario. And in that case, the human actually needs to make the decision that, you dumb machine, you are telling me something, but that's not working in the real world. So I'm going to decide for yourself. And after that, let's say if they do that, is your algorithm going to go crazy, or can it accommodate some of those human decisions as well?
So our head of product is a gentleman named Rick Fisher, and he comes from the WMS platforms where they're so rigid, the employees don't use the system because it's not flexible. Yeah. And you're right. We at the end of the day, we need to remember we don't know best. The employee with the eyes on the ground, they know best. Yep. There might be a spill on the floor, and they can't get to that rack. There might be something broken. There might be the shelf may be broken, right? Yeah. And so if from the ground up in all of our personas that we define for our application, our head of product, Rick, has made it so the employee must always be able to process an exception. And so in traditional WMS systems, SAP wouldn't let them do a put away because they're not standing at the right storage location when they do the scan, and it just won't let them process it. In our platform, we really want to adapt to the human being, and we're passively enforcing. So we're essentially cataloging all of the exceptions and then providing visibility into the warehouse operators, the managers, as to when did those exceptions occur and how often have they occurred. So yes, absolutely. Give the warehouse worker the control. We want the device in the application to be an assistant, not an impediment to do their jobs.
Okay, so let's talk about the interaction of these different systems. So obviously, in your case, you are talking about just the WMS. But when you look at any of the companies, they are probably going to have multiple systems. And since your system is going to rely on the complete data flow overall, because you need to find out, okay, where is the demand coming from, right? That needs to be in your sales order. So if you have multiple channels, for example, you might have e-commerce system, you might have different EDI channels, you might have various different APIs that might be sending the order information, and then you might have email and phone. Those are going to be your channels as well. Maybe your ERP is doing the order processing, and finally your WMS is actually receiving the information to be able to ship, to be able to pick, pack, whatever the WMS is doing. Now, if the WMS is going to be completely disconnected from all other systems, are you going to be okay in your system, or are you going to run into challenges because your algorithm or the system relies on the data from the other systems as well? So what is the assumption here? Are all of these systems need to be connected, or are you simply talking to your WMS?
Yeah, absolutely. So me personally come from, I've only ever worked in enterprise applications, ERP systems, JD Edwards, PeopleSoft, SAP. And so for me, going into this, designing and architecting an application, we knew, number one, we need to be able to run in a disconnected state. So if the ERP system is down for maintenance or patching, we need to function. Number two, we also knew that we don't want to be in a system that essentially decouples the WMS from the ERP, because there's multiple benefits in having WMS information inside of the ERP system for accounting, for production, for supply, et cetera, et cetera. And so our integration strategy to date for Epicor, Microsoft Dynamics, and SAP is one of, we float over the top of the ERP, we synchronize our transactions, you're using out-of-the-box REST services. So we're using APIs. We're not sending flat files. We're not sending XML files. We're not sending CSVs. There's no flat file. There's no batch. We are using modern REST integrations for Epicor, for Microsoft and SAP. We read in purchase orders for inbound delivery, sales orders for outbound, inventory documents, production orders, etc. We cache based on a parameter the customer defines. Do we want to cache 24 hours, 48 hours, right? An ERP system typically is never down for 48 hours, right? So we don't need to cache everything, but we need to cache enough work to handle downtime of system for maintenance or interconnectivity downtime, etc. So the customer chooses a level of cache between the ERP system and our platform, and we manage that in the back end on essentially what we run on Google Cloud Platform. So we operate and we integrate. As an example, let's say you're doing a put away. You're unloading a truck. You're receiving against a PO, and you have material coming in, and in SAP that's called an inbound delivery, and an inbound delivery is linked to a purchase order. We hit APIs in SAP as if someone is transacting on the keyboard in SAP. So SAP doesn't know the difference between us hitting the API, for the users inside of SAP. Michael unloaded a truck. He scanned it. He did a goods receipt. He did a goods receipt against it. He put it away. And then there's the inventory management documents as well. So we use out-of-the-box APIs with SAP. We transact against SAP as if you're using a keyboard with SAP, except our platform is 100% cloud-based.
Okay, so I do have one follow-up question there with respect to the cache that you mentioned, and listeners that might not be familiar with the caching technology that is going to be more of storing the information not in the real time because you are not sure of the real time. I don't know. I mean, see, in the layman terms, I'm trying to describe. Maybe Michael, you can help me here in describing caching.
Yeah, think of it as like a DVR, right? We're recording some shows. We're recording, your inbound deliveries so that you can process them in the event there is downtime on the ERP application.
Right. So that's a much better explanation, I would say, of the cache, just recording in advance, right? So now I am actually going to go back to your scenario related to processing these instructions in real time of your dynamic nature of the warehouse, the way you are processing these instructions. So here you are saying that the information is cached, which means it is recorded in advance. So you are not necessarily operating on the real time data, but your instructions are real time, right?
Right. That's right. It is dual path. And so if the API, if the ERP system is accessible, then we're constantly using the real-time API. Simultaneously, we're caching information. So in the event the connectivity is down, we still have work instructions for the warehouse to work on, right? We still have sales orders, we still have deliveries, et cetera, et cetera. We still have things to work on. But as long as we do basically a heartbeat against SAP every 60 seconds, and as long as that ERP system is up and live, we're transacting live in real time. As soon as that heartbeat fails, we wait for 3 failures, so 3 minutes of consecutive downtime, and then we fall back into sort of the cache. So what POs did we know about? What deliveries did we know about? What sales orders did we know about? And this is for the ERP system today, right? So one scenario you brought up is a customer might have an order entry system that's separate from ERP, and we don't support that today. We will, right? The next progression of development that we're working on is, okay, we've integrated with 3 ERPs. We're going to add 2 more. And then we're also going to be looking to integrate with Force.com and BigCommerce, et cetera, the e-commerce platforms, so that we can synchronize sales orders from the e-commerce platform directly, wait for the ERP process to happen, and then tie everything together at the end, further speeding that time from e-commerce order direct to the warehouse employee.
Okay, very interesting. So now let's move to some of the systems inside the warehouse. So again, we discussed a lot of things from the scanner perspective, that humans inside the warehouse are really carrying these scanners. But if you look at the modern warehouse, there are a lot of things that actually go on right now, right? So you have your ASRS systems, you have your mobile ASRS system, and they are going to have their own network, the way they operate overall, from the way they are actually going to receive the signals from whatever control systems they are trying to use inside the facility. So have you seen any problems just because of the conflict in the control systems? Because you have all of these technologies are being controlled by something, right? I don't know what all technologies are being used in the hardware world, but have you seen any sort of conflict because of multiple technologies being used inside your facility?
No, you're absolutely right. And we are still a young company. We're working on our partnerships with different robotics manufacturers, with ASRS, automated storage retrieval systems. So companies like Swisslog, companies like Locust Robots for AMRs. We're in coordination with them. Essentially, the path we've taken is We are a task engine. We create tasks, right? We
Yeah.
read sales orders, we read purchase orders, we create tasks for the warehouse employee. And a
Yeah.
task can be given to both a human being and a robot. And so in the scenario of an assisted robot where a robot is following an employee, we need to give the pick task to the employee, but we also need to tell the robot the XY coordinates of where to go.
Yeah.
And so we've created a publication subscription engine that our
Yeah.
robotics partners can subscribe to. And within our application, we have business rules that say if it's this product, right, send the task to the robot. If it's this product, send the task to the human being. And so we want to create an ecosystem of robotics vendors that can subscribe, that have the ability to essentially access our API documentation, subscribe as a partner, and be able to subscribe to our task engine so that their robotics platforms can get tasks from fulfilled just like a human being gets a task from fulfilled. That's our vision. To date, to be candid, we don't have any robotics in a customer live today. We are still a very young company and are excited to tackle those challenges when we get there.
Okay, so I know you wanted to cover a few things that we discussed during the pre-show related to overall indoor positioning system and how they are going to impact the operations within warehouse. So do you want to touch on that?
Yeah, I mean, indoor positioning systems are essentially, it's what we've been talking about, right? Creating that digital twin of understanding where a human being is, where a forklift is, where a cart is. Maybe you have maybe you're in an automotive scenario and you have carts with the components that are wheeled into the work center and then wheeled out when they need to be replenished. We need to know where these things are at, right? That's the digital twin, and that's indoor positioning.
Yeah.
I think indoor positioning, there's multiple ways to attack it today. I think everybody in your audience has heard of BLE and Bluetooth Low Energy. Everybody's heard of RFID, active RFID, passive RFID.
Yeah.
We're using a technology in our platform called ultra-wideband that operates in that Wi-Fi spectrum. So it operates in the same spectrum as Wi-Fi. It has similar coverage to Wi-Fi, meaning you know how Wi-Fi can pass through objects. It can pass through walls. It can pass through things. You can still have connectivity. It doesn't have to be line of sight. Wi-Fi can also cover 1,500 to 2,000 square feet, where Bluetooth Low Energy is 150 square feet. So you get 10 times the coverage with the device. So ultra-wideband we think is pretty cool. Just to be honest and share with your audience, there's some competitors out there. There's Android, or Google has a product called Wi-Fi RTT. It's basically using Wi-Fi in an Android phone to calculate position of the phone in a physical space. The next technology that is relatively recent is calculating position when using a private 5G network. And private 5G networks are probably a whole other podcast of why would a company have a private 5G network? But there are reasons, great reasons, to have a private 5G network, and Verizon provides private 5G networks. Singtel in Singapore provides private 5G networks inside of manufacturing warehouse facilities. And in their cellular technologies that they have, they also have the ability to understand a person's position or an object's position based on the cellular signal inside the phone. So I think that throughout the industry, we're going to see indoor positioning becoming mainstream, in that you're going to have it when you go to a large event or a large shopping center or an airport. We're going to have indoor positioning that helps guide you through the airport or through a concert venue or a music festival. And I think we're going to also see indoor positioning in the commercial space, in manufacturing, in warehouses, because you have to navigate robots in the warehouse. They need to know where they're going. That's indoor positioning. You have to prevent humans and robots from having collisions. That requires indoor positioning. So I think there's still yet to be defined industry regulation around robots and human beings working together. But I think indoor positioning is going to be a key component to regulating, keeping workers safe, and then further optimizing the supply chain, just knowing where people are at, where product is at, and getting things to move more smoothly.
And just to be clear, with respect to your comment about 5G, is 5G going to make the indoor positioning better because they are able to create the private network? Can you paint some more colors there?
Yeah, so we have 5G cellular, right? That you can go to Verizon, if you're in North America, AT&T, and get a 5G phone. Great, fantastic.
Yeah.
Well, 5G is very low latent and has extremely is very high bandwidth. It has a lot of capacity. And 5G has tunable channels. So if you think about it in a warehouse, and I know, for example, a robotics company where each robot takes 30 meg of bandwidth, essentially 30 meg, right? Think about that. Yeah. And if you have a standard Wi-Fi network in the building, once you get to 10 robots, all of your Wi-Fi is eaten up by robots, and then your human beings have no Wi-Fi to connect to. You're not going to have enough bandwidth. 5G that's a use case for a private 5G network where Verizon or AT&T or Singtel or whomever your 5G partner would be, even Nokia, they install a 5G network inside of your facility, giving you more bandwidth, less latent, super high capacity. So you can have robots on one channel and human beings on another channel and then equipment on a third channel, and everybody has the bandwidth that they need to do their job or to be functional. So that's a use case for private 5G. Now, there are startups that have figured out ways, and one startup is called Cineon. They were purchased by Verizon recently. They figured out the math of how to triangulate location using a 5G signal. So in a warehouse with a private 5G network deployed, if I'm carrying a 5G phone, I can calculate the 5G phone's position down to about 6 feet, which is way better than GPS, right? The 5G networks, I think you're going to continue to see them grow. They're still very expensive, but they will be deployed inside of manufacturing facilities, warehouse facilities, provide the bandwidth required for robotics platforms, and to provide indoor positioning guidance. I think that's my bet.
Okay, amazing. This has been super insightful, Michael. That's it for today. Do you have any last-minute closing thoughts or advice for our listeners?
In terms of advice, I think it's, this is still, when we think about warehouse operations, as you pointed out earlier, it's still a human-driven world, right? Even Amazon has said in the next decade, they're not even going to have a fully automated warehouse. So, we need to remember the warehouse worker. I came from the warehouse, and I understand the ebb and the flow of the day and how things can move and not move in a warehouse. And everything that I do every day, we have a focus on that end user, the warehouse worker in the warehouse, making sure that their day is as effective and productive as possible and making them feel good. So my big message to everybody is just remember those warehouse workers when deploying WMS systems, when deploying technology, and really centering back to, does this help the employee throughout their day? Does this enable them? Does this assist them? Does it make them feel good and be more efficient in their day? And that's a focus I have in building software, and encourage other organizations, if they put that focus on the warehouse worker, I think they're going to be very successful in what they do.
Yeah, amazing. And my personal takeaway from this conversation is going to be, there's just so much innovation happening, and there are so many technologies out there that can really provide you the competitive advantage, but you really need to understand how that can fit in your organization and how you can put all of those foundational blocks that is going to really provide you that capability. Otherwise, you are simply going to complain that the technology does not work. It does not work because you don't have those foundational components that are going to be required by any technology out there. On that note, Michael, I really want to thank you for your time. This has been a powerful episode.
Thank you so much, Sam. Enjoyed. Hope to come back next year and give you an update on our platform.
Of course. Thank you so much. I cannot thank our guests enough for coming on the show, for sharing their knowledge and journey. I always pick up learnings from our guests, and hopefully you learned something new today. If you want to learn more about Michael or about the warehouse digital twin and cloud-based warehouse management system, head over to fulfilled.io. It's fulfilled.io. Links and more information will also be available in the show notes. If anything in this podcast resonated with you and your business, you might want to check other related episodes, including the interview with Tim Harrison, who discusses various ASRS systems and why they are essential to increase the productivity of a warehouse. Also, the interview with Andrew Johnson, who discusses the evolution of RFID tags and how RFID technology is no longer limited to tracking high-value assets. Also, don't forget to subscribe and spread the word among folks with similar backgrounds. If you have any questions or comments about the show, please review and rate us on your favorite podcasting platform or DM me on any social channels. I'll try my best to respond personally and make sure you get help. Thank you, and I hope to catch you on the next episode of the WBS Podcast.
Thank you for listening to another episode of the WBS Podcast. Be sure to subscribe on your favorite podcasting platform so you never miss an episode. For more information on growth strategies for SMBs using ERP and digital transformation, check out our community at WBS.rocks. We'll see you next time.